So here, they are telling us to find the concentration in grams per liter for each of the following solutions. Find the concentration in grams. Now, the question is as brief as this: the concentration in grams per liter. Grams in a liter. We say the liter is equal to what? The liter is equal to 1 decimeter cubed, which is the same as 1,000 cubic what? Centimeters. Isn't it? This is our relationship we have. Yes?
Yes.
Okay. Now the question is find the concentration in grams per liter. Grams per liter, grams in a liter. Meaning the question, they have given you certain grams in a certain liter of water. Now here they have given you 4 grams in a half a liter. So this is half a liter. Half a liter of what? Of sodium hydroxide. Sodium hydroxide containing 4.0 grams. What about 1 liter? What does it have? 1 liter of sodium hydroxide? Because that's what they want. The concentration in grams per liter. Grams per liter. Our question is in liters, so we don't need to put into decimeters cubed or this. Now, if this is a half having 4, what do you do to make this a liter? You multiply by 2, isn't it? Times 2, then this side also times 2. That is the answer. 1 liter of sodium hydroxide contains 4.0 times 2 grams, which is 80 grams, 8.0 grams. This is the answer. So to write it safely is 8.0 grams per liter. Per liter. Let's look at B part. They want the concentration in grams per liter. They are saying find the concentration in grams per liter of 5.3 grams of sodium carbonate in a quarter a liter. So they are asking you that what does 5.3 grams of sodium carbonate contain? This one is in what? A quarter a liter. So you say a quarter a liter, that's 1 liter divided by 4. A quarter liter of sodium carbonate contains 5.3 grams. What about 1 liter? What does it have? To make this 1 liter, we multiply by what? How do you make a quarter liter? 1 out of 4 of a liter to be 1 liter. You multiply by, if this was a half, we multiply by 2. If it's a quarter, we multiply by
4.
By 4. Thank you very much. So this one times 4. What you do this side, you also do it the other side times what? 4. So here you say 5.3 times 4. What do you get? 5.3 times 4.
21.2.
21.2 grams per liter. That is the answer we have. So we have C. Can you get for me the answer to C? Answer to C is what? 700 cubic centimeters of water, not water, but iron 2 sulfate, iron 2 sulfate contains 1.24 grams. What about in a liter? Okay, a liter is, now they have put the answer in cubic centimeters. Make sure your liter is there up, the relationship we have. So it is 1,000. That's what means by 1 liter. What is the answer? No one has the answer. Yes? People are still doing the work. Maya?
Chef, for me, I got 0.84 grams per liter.
0.84 grams per liter. Cynthia, text me the answer. Yes, please.
I have 12.4 grams per liter.
12.4 grams per liter. Cynthia, well, the answer is 0. What? Wendy, where's the answer? Wendy. Wendy has gone to sleep, I think. Wendy has 8.68 grams per liter. Okay. Let's do the number together and we see that if 700 cubic centimeters of iron 2 sulfate contains 1.24 grams, what does 1,000 have? Cubic centimeters. So this is 1 is equal to 1.24 divided by 700. 1,000 cubic centimeters have 1.24 divided by 700 times 1,000. What is the answer? Is what?
1.77 grams per liter.
77 grams per liter. Now, where did you pass to get your answer?
Actually, me teacher, I got 1.24 out of 1,700.
No, that is the wrong way. If you want to make 1,700, you divide by 700, then the 1,000 is the number. That is what gives us grams in a liter, concentration in grams per liter. A liter is 1,000. or 1 decimeter cubed or 1 liter. That is all. Is it okay?
Yes.
Okay, we have this one D. Then the rest, this E. E we are also going to do it. E we are going to do it. So E is here. What is the answer? 1 decimeter cubed. 0.98 of sulfuric acid in 0.25 decimeters cubed of water. What is that concentration in grams per liter? The answer? Who is ready? Patricia, where's the answer? Yes, Maya.
For me, I have 3.92 grams per liter.
3.92 grams. Thank you very much.
Teacher, I also have 3.92.
Okay. So the correct answer is 3.92 grams because they say, somebody is here. It is true. 3.92 is the correct answer. Say 0.25 decimeters cubed of sulfuric acid contains 0.98 grams. What about 1 decimeter cube? That means they divided this by 0.25. Divide by 0.25. So the answer comes to 3.92 grams per liter. Okay. So finally, give me the answer for E.
The answer for E.
That one should be in less than a minute. The answer for E.
4.67 grams per liter.
4.67 grams per liter. So the answer will be 600. 2.8 divided by 600 times 1,000, isn't it?
Yes.
2.8 divided by 600 times 1,000. So the answer comes to 4.67. Thank you. So now we have known how to convert the grams to liters. Or any concentration, if you are given any concentration to grams per liter. Okay. So if numbers come in that way, you can now get any concentration that you want, as long as you know. So look at number 2, the way it is. Find the number of moles in the following sodium hydroxide. What do they want? They want what?
The number of molecules.
Number of molecules. Okay. Find the number of moles in the following sodium hydroxide. They have given you the volume and the molarity. Last time we looked at the molarity. Molarity has the number of moles in it, in 1,000 cubic centimeters of water, isn't it? So when they put 0.10 molar, the simple way of writing this is starting with 1,000 cubic centimeters of sodium hydroxide solution. Sodium hydroxide solution contains 0.1 moles. What about, okay, there's a 0 here, 0.10 moles. Ask yourself a question. What about 1 cubic centimeter of sodium hydroxide solution? What does it have? Contains 0.10 divided by 1,000. These are the number of moles. What about the volume they have given you? 25.0 cubic centimeters. What does it have? It comes to 0.1 divided by 1,000 times 25.0. What is this volume? What is this mole? What are the number of moles there?
Mm,
Mm-hmm.
0.000025
moles. Okay. So those ones whose calculators are giving in standard form, like mine, this one. Does somebody have an answer that is like that?
Yes.
Now, what do you do to remove or to take back the answer to normal?
Huh?
mod.
Yes. Now, what you do, you press the mod key. When you press mod key, it gives you those readings. Leave complex, leave those things, leave even that one. So you go and look for where they say fix, science, and normal.
Fix, science, and normal.
If your whatever is on,
If
you mute
your
it.
whatever is on,
There is an
you
echo.
mute it.
Okay, thank you. So you look for these words fix, science, and normal. So you take it to normal by pressing the corresponding number. The number corresponding to normal is 3. Press 3. It is either asking you either normal 1 or 2. You press any of those, you will see the changes in the answer. If you put 1, it still remains the same way. So you go back to mod, and look for normal, and then 3, 2. It gives you back the answer in that format. Is it clear?
Yes.
So that is the way you fight your calculator. Never accept to write your answer in standard form, yet you can write the answer in normal form. Okay, what is the answer to B part? First calculate B. Number of moles of sodium hydroxide in 25 of 0.15 molar. The answer is what?
0.00375.
0.00375. Who has a different answer? Frida. Frida. So in simple terms, if these things come, you look at these steps we have here. That to write this word, if they put capital M, this is molarity. Now, if you want the number of moles in this 25, you just divide this by 1000 times 25. Divide the molarity, you get that molarity by 1000 times the volume given. Volume. That is in short. If things come this way, find the number of moles of carbon dioxide in 25 of 0.01 molar. This one is okay. Even this one is still the same thing. The concentration in grams, they have given you certain grams, they dissolve in a certain amount. They want you to find just what 1 liter can have, or 1 decimeter cubed, or 1000 cubic centimeters. So you play around with what they have brought. If the answer is in cubic centimeters, our relationship, we have it as 1 liter is the same as 1000 cubic centimeters, which is the same as 1 decimeter cubed. That is our relationship we have. So like here also the same, cubic centimeters, cubic centimeters. Cynthia, I told you how to change the calculator. Go to mode, press until when you get fix, there's that word fix, science, scientific form, and then the normal. Go to normal, press the letter corresponding to normal, which is 3. If yours is in standard form, look for 3, and then they will bring, is it either normal 1 or 2? So you press 1 and see if there is no change, follow the same procedure up to this, go to normal 3 and then press 2. Okay? Good. So here, I don't want to waste time here. If you have known how to calculate from the first part, the answer to C is what? I'm now going to write the answers down. To C is what? The answer to C is, give me the
That's
number of
right.
moles. Press the calculator very fast. Letitia, you are going to give me the answer to D. Somebody give me the answer to E. Wendy, give me the answer to E. Letitia, the answer to D. And then somebody is giving me the answer to C.
0.
Who is starting with the...
Teacher,
Yes.
for C, I got 0.002.
002, correct answer. For D, D was who? Cynthia, that answer of you is 0.015. Okay. Admitted. D,
0.00125.
0.00125 moles. That's the correct answer. E, Wendy.
0.004 moles.
0.004 moles. Let me prove it. 0.2 divided by 1000 times 20. Congratulations. Now we can calculate those numbers and finish them. That is the way those questions come. Now, this is just a by the way, and it gives you an idea of how questions are calculated. But the real exercise for this comes like this. Standardize hydrochloric acid using sodium carbonate by finding, number one, molarity. What did we say molarity is?
The number of
The number of moles in what?
In one volume of a substance.
Not one volume, but 1,000 cubic centimeters of any substance. If it's not like that, 1 liter. If it's not like that, it's 1 decimeter what? Cubed. So the number of moles in this volume, any of this gives you molarity. So here they are asking standardize. That means if they say standardize, this word should not tease you. Meaning hydrochloric acid, everything about it is not known. You get it? They might have given you only the volume. You see this? 25 cubic centimeters of hydrochloric acid require the 32 of 0.5 molar sodium carbonate. Do you see this? Have you seen this part?
Yes.
This is like
Yes.
the second part we have been doing here. Okay? Then this other part now, they have given you only the volume. So what is missing is the molarity here of this thing. Okay? So these questions should never scare you. If they say standardized, that means that the hydrochloric acid, one of those things has not been given, either concentration in moles per liter or concentration in grams per liter. So they want you to get its molarity, one, then the concentration in grams per liter, using sodium carbonate. Now, sodium carbonate, they should have given you everything about it, either volume and the molarity. Okay? So if you are calculating this, the first thing for you to write is the equation of reaction between hydrochloric acid and what? And sodium carbonate. So if you write sodium carbonate, I told you when I'm writing sodium carbonate, if you don't know how to come up with the compounds, first start by writing sodium carbonate somewhere. How do you write sodium is Na, it has 1. We saw it in the periodic table. It has 1. Then the carbonate is a radical, it is C2, and it has a valence 2. The whole of this. So when you're writing sodium carbonate, the 2 goes there, 1 goes this side. So sodium carbonate is written as this, CO3. Okay? Hydrochloric acid is very easy. It is HCl. So we shall write sodium carbonate. What was the state? Aqueous plus hydrochloric acid, aqueous also. What do you form? Sodium is more reactive than hydrogen. It takes away the chloride. Yes, so it becomes sodium chloride plus what? Carbon dioxide gas plus our equation. Let me write it here. I want it to be in a single line. Sodium carbonate aqueous plus hydrochloric acid aqueous. We get sodium chloride aqueous also plus carbon dioxide gas plus
Water.
This is a reaction between a salt and an acid. The end product is, if it is a carbonate, we find carbon dioxide and water. So now what follows is to balance the equation. This is a gas, this is a liquid. Now sodiums, there are 2 here, here we see 1. So start with those ones, 2 and then 1. So here we see 2 chlorides. I see 2 hydrogens here. So check here. Do you have 2 chlorides, 2 hydrogens? No. So you put 2. Then carbonate, check if a carbonate is balancing. 1 carbonate, 1 carbonate. Oxygens are 3 here. Here we have 2 plus 1, 3. Therefore, the equation is what? Balanced. After that, write the solutions whose concentrations are known. An example, sodium carbonate. They have given you molarity. They have given you the volume. Okay. So you start with 0.15 molar. Do you know how to write this English-wise? The way you write this English-wise is by saying 1,000 cubic centimeters, because our answer, the volume we have given us in cubic centimeters. Okay. So 1,000 cubic centimeters of what? Of sodium carbonate what? Solution contains what? Contains 0.15 moles. Isn't this what we have been writing up here? Yes? So what about 1 cubic centimeter of sodium carbonate solution? What does it contain? It is 0.15 divided by 1,000. These are the moles in 1. What about what volume was given? 32.00 cubic centimeters of the same thing. What does it have? 0.15 divided by 1,000 times 32.0 cubic centimeters. These are moles. What is the answer there?
0.0048.
0.0048 what? Moles.
Moles.
Now, you cannot shift from sodium carbonate to hydrochloric acid if you don't know the mole ratios. We saw these calculations a long time ago. The only way you can shift from this to this is using the equations, and they give you the mole ratios to which those things react. Now, you write here, from the equation of reaction, 1 mole of the carbonate, 1 mole of sodium carbonate, isn't it? From the balance equation, here we have only 1 mole, isn't it? Yes? People are quiet. What has happened? 1 mole of sodium carbonate reacted with how many of the acid?
2 moles of hydrochloric acid.
2 moles of the acid. Now, what about these moles of the carbonate? What about 0.0048 moles of sodium carbonate? It reacted with what? Reacted with 2 times 0.0048 what? Moles of the acid. This one is of the acid. So what are those moles? 2 times that answer, what do you get?
0.0096.
0.0096 moles. Now these are the moles. If these ones were in 32, okay? If these ones were in 32, where do you expect this volume to be? These moles, where would you expect them to be? If these ones of the carbonate were in 32, now these ones were in how many? Check if you are given the volume of the acid. Now, if you have the volume of the acid, then it's better. So now this volume, since this volume reacted with this volume, this one required this volume. Therefore, the moles you have calculated here were in, these moles were in?
Acid.
They were moles of the acid. Which volume had those moles?
Was it 32.00?
No. Here. It is this
The
volume.
hydrochloric.
This one. Because these moles are for hydrochloric acid, these ones we have calculated from the equation of reaction. Okay? Ask yourself a question. So these ones were in 25. So then you say 25.0 cubic centimeters.